everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. The topic for discussion today we have taken is double integrals in polar coordinates. This video lecture we will discuss about regarding double integrals in polar coordinates or definition of double integrals in polar coordinates, and we will solve few problems based on double integrals in polar coordinates. The introduction to double integral in polar coordinates, that is, here this is the interior integration, that is, here the lower limits is r1, the upper limit is r2, the outermost integration, the lower limit is theta 1, the upper limit is theta 2, and the function which is defined in terms of radius and angle. And we will do with respect to r and with respect to theta integration. When we are doing integration with respect to r, theta is treated as constant. If we do integration with respect to theta, r is treated as constant. This formula represents the polar form of the double integration. This integral is first integrated with respect to r. If it is r, keeping theta as constant, and finally the resulting expression, that is what we integrated with respect to r and theta is treated as constant, then we will move to again the integration that is integrated with respect to theta. The problem evaluate integral, the interior one is 0 to pi by 2, the outer integral is, the limits are from 0 to infinity. The function which is given e power minus r square r d theta dr. This double integral we have to do evaluation. This is our question. We will move to now solution. The first we are starting the solution with given. What is the question is given? Once again it is written. To avoid the careless mistake, the interior one, the integral, this part it is written that we put it in a separate square bracket. So to avoid the confusion, the square bracket what it is kept, even though the question is double integral, to avoid the confusion, we are treating it as a single integral. So the interior one only we have written. The idea is after solving this, and we will substitute in the particular place. Now, here the integration is with respect to theta. So there is nowhere this r connected. So when we are doing theta with respect to theta integration, r is treated as constant. That is the reason before integral we have written regarding r terms. So e power minus r square r integral 0 to pi by 2 d theta. So now here e power minus r square r, and this d theta, the integral is, if you do the d theta, the integral is theta. So the limits are from 0 to pi by 2. Now this as it is written here, we didn't touch at all. Only the theta place we are going to substitute the upper limit, that is pi by 2, we substituted and we got it pi by 2. This is minus, formula minus, we know it upper limit, formula minus, lower limit. Lower limit is 0. In the place of theta, we substituted. In the place of theta, we substituted. We got it 0. So the finally, pi by 2 e power minus r square r, we got it. This is only our question. So this double integral, this we did separate, and here all the steps we did. Finally we reached, this is the result. Now what we are going to do, this particular place is going to replace by this result. So double integral, we are imagining it is a single integral. These steps we are following only to avoid the careless mistake. If we want this particular place keeping, also we can do it. That is also correct. Now this particular place, this result, we will replace it. So now this entire part, it is replaced, this result. This integral is written as it is. This dr is written as it is. Next, the pi by 2, a constant, that it is written before the integral. E power minus r square r dr. This we have to do the integration. Now, this integral, it is a complicated one. In terms of r, it is there. Is there any substitution method? That is to make our this complicated integral, or is there any easy way? We are finding the substitution method we are selecting. That is, in terms of r, it is there. The entire integral we will change into in terms of t. So we are assuming r square as t. We are doing the differentiation both the sides. R square, it's nothing but 2r dr, and t is nothing but dt. This r square, we know it, the differentiation formula, x power n, it's nothing but n into x power n minus 1. Our n is 2. So 2r, 2 minus 1, it's nothing but 2r. That's what here. The differentiation, we got it 2r. When we are changing the entire r in terms of t, then we have to check, is there any changes in limits? For that purpose, when r equal to 0, we are substituting in this particular place r equal to 0, then we are getting t equal to 0. So here, the lower limit, there is no change at all. Next, here r place we are putting infinity. Here also there is no change. So t is as it is, infinity only. Now, this pi by 2 is written as it is. Integral, just we copied it. E as e, minus as minus. R square we assumed as t. So it has become t. We want r dr. From here we are picking r dr, it's nothing but dt by 2. So now we are noticing the entire in terms of r, it is there, the integral, it is completely changed in terms of t. So it is changed completely in terms of t. Now, here pi by 2 is there, here 1 by 2 is there. both together it is becoming pi by 4. So integral 0 to infinity e power minus t dt. This integral is very simple, that is pi by 4 as it is. E power minus t is e power minus t divided by the t coefficient is minus 1. So divided by minus 1, 0 to infinity. Before substituting these limits, is there any simplifications? We simplified it. So pi by 4. Just this minus sign we brought up. It has become minus e power minus t, 0 to infinity. We know e power minus infinity, the value is 0. E power 0, the value is 1. Now, pi by 4, here we substituted minus e power minus infinity. This is formula minus, and this one is minus e power 0. That is, t place we substituted minus infinity, that is the upper limit. Here the t place we substituted 0. It's not minus infinity, infinity we substituted. Here the minus sign, it has become here again. So now pi by 4, e power minus infinity is 0. So the upper, the limit value after substituting, we got it 0. The formula minus as it is. E power 0 is 1, but before that minus sign is there. That is the reason it has become here minus 1. This minus and this minus put together plus 1. So pi by 4. So we completed the one problem. We'll move to the next one. Evaluate double integral. The interior integral is from 0 to 2a cos theta. The outer one is 0 to pi by 2, and the function in terms of r and theta, it is given r square sine theta d theta dr. So if it is f of theta comma r or f of r comma theta, the function which is defined in terms of r and theta, then it is double integrals in polar coordinates. So the given, what is the equation we have written? Now we are looking, since the inner integration, this is the inner integration, is a function of theta, because here 2a cos theta it is there. That means the interior integration which is defined for r. So we can see it here. Since the integration limits depend on theta, the function is integrated with respect to r, it is given here. If it is a function of theta, then we can write r equal to r equal to. Then it should be integrated with respect to dr. But here in the equation, d theta is there, that we have to change it. So whatever the double integrations are given, the interior one with respect to r, with respect to theta, first that we have to make it very clear picture about it. If it is a function of interior theta, then it is defined for r. Then we have to do the integration with respect to r first. The correct form of the integral. So this is our question, but according to the limit, this is not correct. So we are writing the correct form of the integral. So the correct form of the integral is this one. R equal to 0 to R equal to 2a cos theta. This interior is defined for R. Then we have to do integration with respect to R only first. So again, to avoid the confusion, even though it is a double integral, first we will do the interior one first. After getting the result in this particular place, we will substitute. Lots of careless mistakes will be avoided doing like this. Now we have done it here. The interior one, what we are going to do, that is put it in the square bracket. The leftover, it is kept for the outermost integration. Now we will concentrate only this integral. We are imagining ourselves, even though it is a double integral, to avoid confusions. That is a correct thing. To avoid the confusions, we are treating as single integral. This part only separate we are doing first. So 0 to 2a cos theta r square dr. Now this r square we have to do the integration. Very simple formula. Integral x power n dx. It's nothing but x power n plus 1 by n plus 1. So the r square dr, it's nothing but r cube by 3. 0 to 2a cos theta. Now 1 by 3 we have taken out. R place we are substituting the upper limit, that is 2a cos theta. Substituting in the place of r 2a cos theta, it is written. This cube is coming as it is. This is nothing but upper limit minus, that is a formula, minus lower limit is 0. R place we substituted, it has become 0. Already 3 we have taken out. Now this 1 by 3, it is written as it is. 2a the whole cube, it's nothing but 8a cube. Cos theta the whole cube, it has become cos cube theta. So the interior one, the integral, we integrated, we got this result. So this particular place, we got this result that we substituted. This is the connectivity. Now we will do this integral. So if it is a double also, we treat it as single. Again substituting single. So this is the last step in the previous slide. So integral 0 to pi by 2, 8a cube by 3, cos cube theta, sin theta, d theta. This we have to do the integration. Two trigonometric functions are there and a cube, 8a cube by 3 is constant. So there is no problem at all. Before the integral we can keep it. But these two trigonometric terms, how to do the integration? Now, if you do the comparison before step and this step, suddenly here sin theta is there, but here it has become minus sin theta. And here 8a cube by 3 is there, suddenly here one minus is introduced. How suddenly? Mathematically, whether it is correct? Mathematically, if it is correct in the sense, if we add, we have to do subtract. If we multiply, we have to do divide. Then mathematically, it is balanced. The same concept we have done it here, minus 1, minus 1. That is multiplied. Then it has become minus sine theta. For this we divided, here it has become minus. Why we have to do this suddenly? Now, this integration, it's a complicated one. So few formulas are there that we have to remember. The formula is f of theta power n. F, the function is, first time it is a differentiation it has done, d theta. Like this, the format it is there, the integration, it is there. Now, this part we can leave off. F of theta power n. First, what is f of theta? From here I am picking f of theta equal to cos theta. According to this, we wanted f dash of theta, that is minus sine theta. See the beauty of this integration. We have taken f of t equal to cos theta, f dash of theta equal to minus sine theta. But in the previous step, we have only plus sine theta. We needed minus sine theta according to this formula. But minus sign is missing. That is the reason we did minus 1, up and down, multiply and divide we did. Here the sine theta is replaced by minus sine theta. Everything we have done it to fit this formula. Now, according to this formula, f of theta power n plus 1. If we are taking f of theta equal to cos theta, here n places 3 is there, then here the substituting cos theta power 3 plus 1 by 3 plus 1. So cos theta, that is, we are getting cos power 4 theta by 4. This is the result. We got it after substituting in this formula. So it is written as it is. Here cos power 4 theta divided by 4, 0 to pi by 2. Upper limit is pi by 2, lower limit is 0. So we know the formula, upper limit minus lower limit. In terms of theta, we have to substitute. That is, we did the integration with respect to theta. This 4, 3 put together, 3 4s are 12. So the particular this part, it has become minus 8aq by 12. Cos power 4 theta 0 to pi by 2. Now here minus 8aq by 12. Now cos power 4 theta. So the upper one is pi by 2. We substituted upper limit. Cos power 4 90 degree. Pi by 2 formula minus cos power 4 0. The theta is taking the value 0. Now, here we got it minus 8aq by 12. This particular place it has become 0 because cos 90 is 0. This minus sign as it is. Cos 0 it's nothing but 1. So after substituting the limits, this particular place we are getting minus 1. Already minus sign is outside. Put together it has become 8aq by 12. We gave in the result in the lowest form, taking 4 as common and cutting 2aq by 3 is the result. We got it. So we will concentrate the next problem. Evaluate double integral. Looking at the question, two integrals are there. It is double integral. The functions, it is in terms of r is there, theta is there. So it is polar coordinate. Solution, we will start with given. What is the question we are writing? So it is a double integral. Which one we are going to, this part we are going to concentrate. So it is written here, interior one. So the interior one, the integral, we will do it first. Afterwards, in the particular place, we can substitute. So it has taken out. We know the formula. Integral x power n dx, it's nothing but x power n plus 1 by n plus 1. Here r power 1 is there. Our formula, if it is x power n, we know it. X power n plus 1 by n plus 1. Here n is playing the role 1. So we know it r square by 2. That's what here we integrated the limits from 0 to a sine theta. Now here r is playing the role a sine theta, that is a square sine square theta we substituted, divided by 2. So the completely here the upper limit, the job is over. This is the formula minus. Here the lower limit is 0. We substituted in the place of r. We got it, the result 0. So now a square by 2. This is a square by 2. Sine square theta, we got it. That sine square theta, which is replaced by, regarding the trigonometric formula, 1 minus cos 2 theta by 2. Because sine square theta, to do the integral, it's difficult. That is the reason relevant, the trigonometric formula we substituted. Now, this 2 into 2, 4. A square by 4, 1 minus cos 2 theta. So the interior integral, we integrated, the result we got it a square by 4 into 1 minus cos 2 theta. So this is only our question. This we integrated. This is the result we got it. We are going to do now, replacing this part, this result. Again we will do the integration with respect to theta. This is the very simple way we can avoid the careless mistakes while integrating the functions. Now we replaced it. That is, this place it has taken this value, a square by 4 into 1 minus cos 2 theta, integral 0 to pi d theta. So now here a square by 4 integral 0 to pi 1 minus cos 2 theta d theta. Here it is written a square by 4. We know it integral d theta. It's nothing but theta. This minus sign as it is. Cos 2 theta. It is written sin 2 theta by 2. That is cos 2 theta d theta. If it is only cos theta, we know it, the integral is sin theta. This is cos 2 theta. That is the reason Sine 2 theta divided by the theta coefficient is 2. We are doing the integration, so divided by 2. The limits are from 0 to pi. So this is the last step. Now we will substitute in the place of theta, the upper limit is pi. A square by 4 it is written as it is. The theta place we are substituting the upper limit. So we substituted, the theta is taking the value pi. The minus is written as it is, and sine 2 theta. This theta is replaced by pi. So sine 2 pi, it has become 0. So we completed the job regarding the upper limit pi. This is formula minus for limit. The theta place we are substituting the lower limit 0. So it has become 0. This minus sign as it is. This is problem minus sign. Sine 0 is 0. Completely the work regarding limit substitutions, both upper and lower, we completed. We got it? A square by pi by 4. The next problem is double integral. The interior integral is a function of theta. Then it is defined for r. It is giving the picture. It is polar coordinate because theta and r are there in the functions. The solution, we are starting with given. The question is written as it is. The interior integration, it is a function of theta. So defined for r. So we have to do interior integration compulsory with respect to r, the interior one. Then the result will be integrated finally with theta. So the interior one separate we have written. We are going to do the integration. Our function is r. We know the formula x power n dx. It's nothing but x power n plus 1 by n plus 1. Here r power 1 is there. So r square by 2 after substituting in this integral formula. The upper limit is a of 1 plus cos theta. The lower one is theta. We have taken this constant out 1 by 2. So where we have to substitute only in the place of r square. So we have kept it here. What are the rooms are there for the careless mistake we are avoiding? That is the reason here also the constant we have taken out. Strictly we are keeping only r square. The same r square by 2 keeping also we can do the upper limit and lower limit substitutions. Nothing wrong in it. If you want to avoid careless mistake, these steps you can, the students can follow. Nothing, both are correct. So 1 by 2 of r square 0 to a of 1 plus cos theta. Now this 1 by 2 is written as it is. In the place of r, we are going to substitute a of 1 plus cos theta. After substituting, we are getting here a square 1 plus cos theta the whole square. This is a limit formula, and theta place we substituting 0. Sorry, in the place of r we are substituting. It has become 0. Now 1 plus cos a by 2, the trigonometric formula we are taking. The reason is, this is a square by 2 written as it is. Here 1 plus cos theta the whole square is there. This 1 plus only cos theta is that it is easy to integrate. But 1 plus cos theta the whole square is there. The relevant actually trigonometric formula we are taking. So 1 plus cos a by 2, it's nothing but cos square a by 2. This 2 we are bringing here. So it has become 2 cos square a by 2. Now this is 1 plus cos a, general trigonometric formula. Our problem is 1 plus cos theta. So this completely our formula in terms of a, our problem in terms of theta. So it is becoming here 2 cos square theta by 2. This square is put as theta only. Now these two are getting cancelled. Here 2 square is there. That means 4 is there. Getting cancelled. The remaining is 2. A square is written as it is. Cos square, the whole square, it's nothing but cos power 4 theta by 2. Now, this is our question. This interior part, we integrated. The result, we got it this one. So, this particular place, it is substituted. The outermost integration, that is, we didn't touch it all, just we copied and we have written here. Now, this integral, if it is single term cos, it's very easy to integrate. But we have cos power is 4. So, we decided the substitution method. That is, theta by 2. We are going to assume as t. That is, the behind what is our idea is complete the integral in terms of theta is there. We decided to change in terms of t. That is, theta by 2 equal to t. Both the sides we will do the differentiation. That is, theta is becoming d theta by 2 equal to dt. This 2 is becoming, that's what it is written here, 2 dt. When we are doing the substitution method, the limits we have to check. That is, when theta equal to 0, is there any change in t? So we are substituting here 0. So 0 by 2. For t, there is no change at all. But when t equal to pi, we are substituting here in the theta place pi, the t has become pi by 2. So if it is 0, the t also 0. That is, when theta equal to 0, t is also 0. But when theta equal to pi, the t is becoming pi by 2. So this 2a square we have written before the integral, 0 as it is, but pi it has become pi by 2. Cos square power 4 it is written as it is. This theta by 2 we assumed as t, yes it is written, and d theta it's nothing but 2 dt. Now this 2 we have taken out. 4a square, 0 to pi by 2, cos power 4 t dt. So this is the integration we have to do it. Cos it has the power 4. Now there is a question, the doubt it has coming in our mind. It is ringing in our mind. How suddenly it has written, we have written this way of terms. This 4a square it is written as it is. We have taken help from the reduction formula. That is, in general, this is strictly this formula which is applicable. The integral, the limits from 0 to pi by 2 only. Even ours also 0 to pi by 2. Then, if it is n is even, our n is also even. That is 4 is our power. Then we can substitute in this formula. We are substituting n place 4. So it is becoming 4 minus 1, 3. The down is 3 by 4. So the next we are substituting here also 4 minus 3, 1. Here 4 minus 2, we are getting 2. 1 by 2. So 1 by 2, the last term we can go. 1 by 2 into pi by 2. If it is even, then we can adopt this formula. Suppose our equation is cos power 5, then it is odd. We have to use, this is the formula. So this problem also we completed taking help from this reduction formula. We integrated and the result, the final result is 3 pi a square by 4. We will come to a conclusion of this video lecture, double integrals in polar coordinates. So the first we discussed, this is the formula. Here theta 1 should be there, theta 1, theta 2. That is integral, the interior integration from R1 to R2. The outermost integration is theta 1 to theta 2. F of r comma theta dr d theta. Focusing on the interior integration, whether it is a function of r or theta, according to that we have to do the integrations. That concept we focused here. We have taken the first, this is the formula we have taken. The problem we solved it. The next, here the next problem, here the interior integration 0 to a of 1 plus cos theta we have taken. The next one is the function, different function, r square into sine theta. The interior one is 0 to 2a cos theta. The outer one is 0 to pi by 2. One more problem also we discussed it. That is interior integration from a to a sine theta. So the different problems we discussed regarding double integrals in polar coordinates. Thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.